In this video, I'm going to continue talking about multiplying and dividing rational expressions. For these examples, a lot of it's going to have to do with factoring and simplifying, as we've seen before. So for this example, I have x squared plus 5x plus 6 over x squared plus 7x plus 6 times x squared plus 4x plus 3 over x squared plus 6x plus 8. Okay, well, I'm going to have to factor each and every one of these four terms, and then I can see what I get. All right, well, for the top left-hand one, that's a leading coefficient of 1. So I have to come up with factors of 6, which add to 5. I think 2 and 3 will work. So x plus 2, x plus 3, right? Now, x squared plus 7x plus 6, this is also a leading coefficient of 1 problem. So I need to come up with factors of 6 that add to 7. I think 1 and 6 should fit. Okay. Now, x squared plus 4x plus 3, also a leading coefficient of 1. So I have to find the factors of 3, which add to 4, which I think would be 3 and 1. So x plus 1, x plus 3. X squared plus 6x plus 8, again, leading coefficient of 1. I have to find the factors of 8, which add to 6. Looks like 4 and 2 would work. So x plus 2, x plus 4. Okay, I factored all four trinomials. Now I just need to cross off what I can. So it looks like I have an x plus 2 here and an x plus 2 here. So those can get reduced to 1. I have an x plus 3. I don't see another x plus 3, so I can't do anything with that. X plus 1, I have one here and here. And I have an x plus 6, but that's a 3, so I can't do anything with that. And the 4, I can't do anything with that. So it looks like I have x plus 3, x plus 3, x plus 6, x plus 4. Doesn't really look like I can do much else. If you want, you can simplify this a little bit more by just writing that that's squared, x plus 6, x plus 4. Okay, that's going to be the final answer. So that is the best we can do. We can't simplify any further. Okay, what about this one? Well, x squared plus 3x minus 28 over x squared minus 13x plus 36 times x squared minus 4x minus 45, x squared plus 5x minus 14. Okay, well, let's see what we can do. For this top left-hand trinomial, this is again a leading coefficient of 1 problem. So for this, I'm going to have to think of what I could multiply. What are the factors of negative 28, which would add to 3? And I found that negative 4 and 7 worked for me. X plus 7. Negative 4 times 7 adds to, multiplies to negative 28, and those add to 3. So that would be the correct factors. All right. For x squared minus 13x plus 36, this bottom left-hand trinomial, I have to find the factors of 36, which would add to negative 13. And I think they would be negative 9 and negative 4. X minus 9, x minus 4. The minus 9 and minus 4, those multiply to positive 36 and add to negative 13. Okay, what about this top right-hand trinomial? X squared minus 4x minus 45. Again, a leading coefficient of 1. I noticed that 45 is a multiple of 9 because if you add them, you get 9. So this is definitely a multiple of 9. Is that something we can work with? Yeah, I think so. I think 9 and 5 would work. So for that to work, we'd have to have minus 9 and x plus 5. Okay. And bottom right-hand trinomial, x squared plus 5x minus 14. Leading coefficient of 1, so I need the factors of negative 14, which add to 5. Seems like 7 and 2 would work. I think it's going to have to be a positive 7 and negative 2. So x minus 2, x plus 7 seems to work. Okay, well, let's see what I can cancel out. I have an x minus 4 here and an x minus 4 here, so those can go away. I have an x plus 7 here, an x plus 7 down here. Those can cancel. I have an x minus 9 here and an x minus 9 here, so those can cancel. I have an x plus 5, but I don't see an x plus 5. And I have an x plus 2 down here, but I don't have one up there. So final answer, x plus 5, x minus 2. Okay, that would be fully simplified. All right, let's look at the next problem. Here I have x squared minus 4, x squared plus 9x plus 14, x squared plus 10x plus 25, and x squared plus 3x minus 10. I notice that the top left-hand corner is a difference of squares, a square minus square, and I have that memorized, so I can say that that's x plus 2, x minus 2. Bottom left-hand corner, I have x squared plus 9x plus 14. That's a leading coefficient of 1, so I need the factors of 14, which would add to 9. Seems like 7 and 2 would work, so x plus 2, x plus 7 seems to work. X squared plus 10x plus 25. This seems like it's a perfect square since x squared and 25 are perfect squares. So this seems like it would be x plus 5 quantity squared. 2 times 5 is 2x, or 2 times x is 2x, and 2x times 5 is 10x, so that is a perfect square. And then x squared plus 3x minus 10. Well, I need the factors of negative 10 that would add to 3x. It seems like 5 and 2 seem to work. Since I need them to add to be positive, I'm going to have to go x minus 2, x plus 5. Those multiply to negative 10 and add to positive 3. Okay, so I think I've factored all 4 trinomials. Now I can just reduce what I can. I have an x plus 2 here and an x plus 2 here. X minus 2, x minus 2. X plus 5, I have an x plus 5 here, but only 1, so I can cancel the squared. And I don't have another x plus 5. I have an x plus 7 in the denominator, but I don't have one in the numerator. So this would be x plus 5, x plus 7 as the final answer. Okay, let's look at another example. 5x minus 20 over 8x minus 40 divided by x squared minus 8x plus 16 and x squared minus 10x plus 25. Okay, well, I'm noticing that these two expressions over here are not trinomials, so I'm probably going to have to do a greatest common factor if they're factorable at all. And I see there's a division symbol, so I'm going to have to flip this upside down to be able to simplify it. Yeah, so let's go ahead and try. So if I factor out, 5 and 20, it looks like I can take out a 5. So I have x minus 4. 8 and 40, I can take out an 8, x minus 5. Then we have the division symbol, so I need to flip these upside down. So I'm going to put this one right here and the top one downstairs. Okay, again, this is division. I'm going to make a multiplication problem so I can simplify it. So I'm going to put the denominator as the numerator and the numerator as the denominator. So star will go with star and dot will go with dot. Anyway, so this denominator here, x squared minus 10x plus 25, well, that looks like a perfect square since x squared is a perfect square, 25 is a perfect square. This looks like it's x minus 5 squared, similar to a previous problem we just did. And then x squared minus 8x plus 16, again, that looks like a perfect square of x minus 4 squared. Okay, let's see what we can reduce. Well, I have an x minus 4 here. I have 2 of them down here, so I'll cancel the 2. I have an x minus 5. I can cancel, since I have 2 in the numerator, I'll cancel that one. And that's about it. That's about all I can do. I can't reduce 5 and 8. So I have 5, x minus 5, 8, x minus 4. Okay, and that's the final answer. That's the most reduction we can do. So There we go. If you want, you can distribute this out if you prefer that, but it would all. This is also an acceptable answer. So 5x minus 25, 8x minus 32. So either way, they're equivalent statements, however you prefer it. All right, let's look at this example. 11a minus 55, 9b plus 9 divided by a squared plus 4a plus 4, and then ab plus a plus 2b plus 2. Okay. Well, again, we're going to have to flip this upside down, and so we can multiply it. Maybe it would help if I just factored it now, so when we flip it, we don't have to factor it while we're doing that step. Okay, so what would I do for this? I have a squared plus 4ab, so this is going to be a plus 2 squared, since that's a perfect square. A plus 2 quantity squared. What about here? It looks like this has 4 terms, so we always want to factor by grouping if that's the case, and so that's what I can do. I can factor out an a, and then I have b plus 1. I can factor out a 2, and I have b plus 1. I notice that these are the same, so that's good. So it looks like that would be a plus 2 squared over b plus 1, a plus 2. Okay. Now I did that so when we flip it upside down, it's not quite as confusing. Hopefully. So 11, let's factor out the 11, a minus 5, factor out a 9, b plus 1. Now I need to flip these upside down. Again, I can put dot and star, so that means that it's going to be dot and star when it's upside down. Okay, this should not a triangle but a star. So this is b plus 1, a plus 2, and then this is a plus 2 squared. All right, let's see what we can cancel out. I have an a minus 5, no a minus 5, so I can't get rid of that. A b plus 1 here and here, so I can get rid of that. A plus 2 here, and I got 2 of them there, so I can cancel the 2. And that's it. That's actually all I can do. 11 a minus 5 and 9 a plus 2. And that's the final answer. Again, if you prefer, you can redistribute this out. 11a minus 55 over 9a plus 18, but they're equivalent statements, so you can do either, whatever you prefer. Okay, so I hope this helps. Let me know if you have any further questions, but that should be it.